Hi guys, cycle 3, week 14, using Van Cleve. We are doing 2 experiments today, numbers 83 and 84. I'm also using from Cyce Connected, Nicole Liam Yang's notes. So these are really excellent on Cyce Connected. So number 83 is called Not at the Same Time. So today we're going to see how matter takes up space. Let's learn how matter has mass and volume. So what kind of questions might we have if you know we're going to be talking about matter and volume? What is matter? We talked about it last week. Do you remember what matter is? It's that all physical objects are made up of this. Matter is anything that has mass and takes up space. That's what matter is. And volume, do you know what volume is? It measures how much space something takes up. Okay, what was another question you might have? Like maybe, how does matter combine to make the things around us? Right? Like most of the things around us are made of multiple things, not just one thing. So how does that work? What have we learned already? We already talked about how we knew about matter from last week a little bit. We already knew about volume just a little bit too. Do you know anything else about matter? What do you know about atoms or molecules? What do you remember from last week? All right, so we're going to learn some more about these things. What do you think is going to happen when we place a marble into a cup filled with water or half full of water? What do you think is going to happen? What will happen to the water? Do you have any ideas? Do you have a hypothesis? Well, why don't we find out? So we're going to start by, I really like to use my beakers rather than tape. It's just really easy. And I got these beakers off of Cornerstone Educational Supply. They're great. They're just plastic beakers. This is a 200 milliliter, 250. I'm just going to pour it up to 150. We don't have to be as precise as last week, but it's good to just get it to a line. So I got 150 milliliters. And now I'm going to choose 6 marbles. 6 marbles. Okay, I got my 6 marbles. And now one at a time, I'm going to let the marbles go in. And I'm going to tip my cup. And I'm going to let my marbles roll in. Because I'm not trying to splash the water. We don't want to lose any water. We want to make sure all of our water stays in there so that we know our experiment is correct. Okay? All right, I'm putting all 6 marbles in. Remember, we put in 150 milliliters of water. Okay, so now I'm going to stand it back up. We can let the water settle a little bit. And now I'm going to look at it and see what we're up to. We are clearly up to about 109, let's see, it's by tens, 170 milliliters. It's a very obvious increase in volume. Do you see? Tip it that way so you can see better. Yeah, so our volume increased when we added matter to the water. So why do you think that happened? What are your thoughts? Remember, all of the physical objects around us are made up of what scientists call matter. Matter is anything that has mass and takes up space. The fact that all matter takes up space is very important to scientists. In fact, scientists know that 2 objects cannot exist in the same place at the same time. In the beginning of our experiment, the cup was half full of water. So we filled it with, 150 milliliters of water. Each tiny water molecule took up space in the cup. As we added the marbles sank and had to push the water molecules out of the way. This made the water molecules rise higher in the cup, so the water level rose. It proves that water and marbles cannot exist in the same exact space. Whether molecules are in solid, liquid, gas, or plasma form, scientists can still measure them. Chemists in particular measure and observe the properties of each type of atom or element. You remember our periodic table from last week? To find out what makes it unique. Some traits are physical properties that you can observe with your senses. Remember what our senses are? Sight, smelling, taste, touch, hearing. I think I got them all. Maybe I missed one. But the things that we can experience about the physical properties of these elements could be their color, their odor, how they smell, how they melt, what point they freeze at. And there are other traits that are called chemical properties, like how flammable they are, which means how quickly will they catch on fire, or their reactiveness to other elements. The atomic mass, or the amount of matter in each element, is such an important property that it's listed on the periodic table under every element to help identify it. So we talked about that, like last week we saw how the rubbing alcohol added to the water had a different volume, had a lower volume than we thought that it would. So in this case, it wasn't that two objects existed in the same place. Remember, that wasn't what it was. It wasn't that water and alcohol were existing in the same place. It was that the alcohol was fitting around the water molecules. So that's a different kind of thing. All right, so moving on to our second experiment of the day, number 84, dry paper. So I'm going to pour my water. I need my cup, so I'm going to pour my water out. I'm going to retrieve my marbles. And I'm going to dry my cup out because I need a dry cup. All right, so I can use this same cup for this next experiment. I'm going to dry my cup out and then we will start talking about it. Today we're going to talk about how air takes up space. Let's learn how air is made of molecules. So what kind of questions might we have? Maybe like, what is air made of? How does it take up space? What have we already learned about air? Does hot air rise? What about cool air? What makes wind? What do you still need to find out? Which of those elements that we've seen on the periodic table are gases? And how do gases behave? What will happen to a paper towel in a cup when we place it upside down in a bucket of water? You might have seen this one before. If you have, don't tell. But we are going to find that out today. What is going to happen, okay? So what exactly is in the cup? I've got my roll of paper towels here. I'm going to ball it up. This is dry paper towel. Make sure it's dry. Okay, I'm going to ball it up. I'm going to stuff it down to the bottom of my cup. I want to make sure it's going to stay. So if it doesn't stay, I'm going to add some more paper towel. All right, that's pretty good if I just don't shake it, okay? So we've got our dry paper towel in our dry cup. What do you think is going to happen when we put it straight down into a bucket of water? All right, let's find out. Here I have my bucket. And it's really important that I go straight down all the way till the cup is underneath the water and I come straight back out. I don't want to ever tip it. If I tip it, this is not going to work right, okay? So make sure I go straight down. So straight down, push, push, push. It kind of gives you some resistance. So I've got the cup completely submerged in the water. And then I'm going to come straight back up out. All right, I'm shaking off my cup. Let's reach in here. Oh, my paper towel is completely dry. Not a drop of water on it. So what just happened? What just happened? How in the world did that work? Air molecules take up space just like water molecules do. We've learned that two objects cannot exist in the same place at the same time. The cup had a paper towel in it, but it was also filled with air molecules. When you placed the cup upside down in the water, the air stayed trapped inside. The pocket of air kept the paper towel dry. Even though we can't see air, it is still made of atoms and molecules and takes up space. If you blow into a balloon, you can see it expand with the air from your lungs. The air we breathe is made up of different gases, and scientists study all the properties of gases just like they do for solids, liquids, and plasmas. Each of the different states of matter actually take up space differently. Solids, for example, hold a definite shape and have a definite volume. Remember, volume is how much space it takes up. Liquids, however, have a definite volume, but not a definite shape, right? Because if I put water in here and I tip it this way, then it's like shaped kind of wonky. And if I put it back like this, it's a little bit closer to a rectangle. If I started swirling it, I could make it have like a cone shape down through the middle. So liquids will fill the space that they're in. If I pour it into a cup that's shaped really funky, it will just take the shape of that funky looking cup. Gases are unique because they don't have either a shape or a volume. They will fill any container they're in just by spreading their molecules out. So that is why when we dipped our cup in, the air molecules were already taking up space, so the water couldn't come in because the air molecules were there. Now, if we had tipped it, what do you think would have happened? If we had tipped our cup down inside, if we had tipped it, the air would have been able to come out and the water would have rushed in, right? But doing this trapped the air. Keeping it nice and upright going down trapped the air. If we had done this, the air would have been let out, which would have let the water in. So that's why that's so important.